All right, we are live. Okay, functions and rules and tables. There's some vocabulary that's going to go with it. And again, the vocabulary is not because you're going to have a vocabulary test. The vocabulary is because you are going to be asked to do some certain instructions, and there will be directions given to you. And if you don't know the vocabulary, then you're not going to know how to do it. So starting with the domain, it's a set of all numbers called inputs. Okay. And then the range is the set of all numbers called outputs. That stuff's already written down for you. You should have that on a handout. Domain and range go together. Inputs and outputs go together. And as you can see here, there's a set of how you would write that. It's kind of like coordinates. Input goes with output, domain goes with range. But also sometimes we can call it the independent and dependent numbers. You've heard that before in science. Independent, dependent. Independent means pick whatever number you want. Dependent means, well, it depends on what number you picked. If I pick 7 and I told you to add 5 to it, you would get the number 12. Everybody would get 12. You don't get to pick whatever you want. I said take 7 and add 5 to it. Everybody has to get 12. So it depends on what number I give you. If I pick 11, that's independent because I just picked it however I wanted. Add 5 to it, I get 16, but everybody gets 16 because it depends on it. So what I'm going to do, I'm going to add to this list and kind of sneak it in here. A lot of times you'll see them as X's and Y's because we put them on a graph. So the X's are like inputs, domains, independent, and the Y's are like outputs, ranges, and dependent. All right, go ahead and take a look. I don't think there's anything else left on here. Identify the domain and the range of this function. It's giving you inputs, so basically it's kind of a vocabulary question. The math today, by the way, is not going to be very difficult. The math is relatively easy. It's the vocabulary and being able to relate to what they're saying. The inputs are 0, 1, 2, and 3. What they're asking you is, do you know what the domain is? The domain is the same as the input. It's 0, 1, 2, and 3. They're just making sure that you know that domain and input go together. The range, oh, by the way, in your domain, you can't shortcut it and say, I'm going to put 0 to 3. That's not okay, because these are only whole numbers. If you said 0 to 3, that means 2.5 counts, 1.5, 0.99, 3, or 2.8. You don't want all those numbers. You only want the whole numbers 0, 1, 2, and 3. The range, you're probably tempted to put the output numbers down and put 5, 2, 2, 1. That's not how we do it. For the range, you put them down as in order. 1 is the lowest number, so you put the 1 first. And then because you're already going to tell me that 2 is in the range, you don't have to write the 2 down again. You already told me that 2 is in the range. It just happens to be in there twice. And then 5 is also a number that's in the range. So that's the kind of math we're doing to start. It's just basically, do you know that domain and input go together? Do you know that range and output go together? All right, I have this picture of this function machine. These are the inputs. You're going to put an X in, and out pops a Y. You're going to put in an input, out comes an output. Put in a domain. It's going to do something to the domain and spit out a range. You're going to put in an independent variable, and it will spit out a dependent variable. And I will use that for you. I'll show you in a moment. With the word function. So that was a function machine. And the word function says each input is paired exactly with one output. And that's really confusing the way it's written. But it's the best way to describe it. And I'm just going to talk through it like it's a function machine. Each input is paired exactly with one output. So you can't put something into the function machine and then have 2 different things come out of it. That's not okay. Like here's our function machine. We can't put an X in here and then out the bottom pops out a Y and a Z. whatever you're putting in there, there's only one construction or one function that's going to happen. I like to think of it as like a cotton candy machine. If you put sugar in here, this spins it to death and out pops cotton candy. You don't put sugar in a machine and pop out cotton candy here and popcorn over there on that side. It doesn't work. So if you put in an input, you can only get one output to go with it. And we'll just do some examples where it says, tell whether the pairing is a function or not. On the first one, it says input output.
Oh.
And because we put a 4 into the machine and it spit out a 3, so far so good. We didn't put in a 4 and then it spit out a 3 and a 12. It only kicked out one output. We put in an 8 and it kicked out a 2. We put in a 2 and it kicked out a 1. So yes, this is of course a function. Everything we put in the machine, it kicked out something of its own. So go ahead and write yes, that it's a function on your paper next to your chart. Different organization and way of representing it, it's the same thing. We could have put 2, 2, 3, 4 in that oval and 2, 4, 6, 8 in the other oval. But take a look at this one. This one's different because this says I put a 2 in that machine and it spit out a 2. And then I went back and I put a 2 in again and it spit out a 4. I just got done showing you on here, you can't put a 2 in this machine and have that 2 spit out. The first time out comes a 2 and the second time out comes a 4. That's not okay. Again, it's like I said, it's like putting sugar into a machine and spitting out cotton candy and popcorn. So this one is not a function. And when you write no or not function, I want you to circle the two output or input numbers and say, that's not okay. You can't repeat the input. And maybe that would help if you put that up in the directions up here. Each input is paired with exactly one output. You can't repeat an input. You can't repeat the input. The only way you could is if you got the exact same number. Well, why would you do that twice? That doesn't make any sense that you'd write it twice. We'll practice a couple more of them. It says try these. If you try this one, is it a function or isn't it? Looks a little bit different. We're back to the oval. We put a 0 into the function, and it kicked out a 2. Yeah, next page. Apparently, you put in a 0 again, and this time it kicked out a 3. Is that okay? Not okay. Even though they didn't write the number 0 twice, they just put it up here twice, they still used it twice when it went this way and this way. So no, it's not a function because you can't have a 0 be a 2 and a 3. But then here's where it's going to get tricky. I said you can't repeat the input. Cannot repeat the input. What about the output? It didn't say anything about the output. It just said if you put in an input, only one output came out. So if we put in a 3, we only got a 1. We didn't repeat the 3, the 6, the 9, or the 12. This had 2 different repeats. Doesn't matter. That's okay. It had 2 different repeats in it. That's okay. Yeah, it is still a function. Having a repeat of these numbers and these numbers is actually okay. And if I go back up to the function machine again, what that's basically saying, we'll still make it a cotton candy machine. You're putting into this function box some sugar and some pink food coloring, or blue if you like that better. You put in the sugar, you put in the pink food coloring together, they still come out with cotton candy. Or you put in the seeds for popcorn, and you put in the oil, and out comes the popcorn still. You didn't change anything, what happens. It's okay if, oh wait, I said that backwards, I'm sorry. Let me go back to this. It's okay if we have a repeat, sorry. Let me go back to this, the way I said it on here. For output, forget what I just said there. It's okay to have 2 different outputs. or the output being repeated. It's okay to have the output being repeated. It is still a function. All right, so moving on from there. Make a table for a function, identify the range. Y equals x plus 1, 0, 2, 3, and 6. Up here, I want you to write, we're calling this the rule. That's the rule. When it said make functions as rules and as tables, the rule is mathematical. The domain, we already know, we're going to put that in first. Domain. This time it just so happens to be called domain and range. Next time it might be called input output. Go ahead and put the numbers in order. 0, 2, 3, 6. If you put those numbers in a domain, the range that comes out depends on the rule. The rule is what's sitting in the box. If you put in a 0, 0 plus 1 is 1. 0 or 2 plus 1 is 3. 3 plus 1 is 4. 6 plus 1 is 7. As I said, the math isn't going to be challenging today. All it's asking you to do is add 1 to the 4 numbers. It's a matter of keeping track of what's domain and what's range. Range 1, 3, 4, and 7. Right. That's not a trick question. They just want to make sure that you know that the range are those 4 numbers that come out in the bottom of the table. Go ahead and try this one yourself. Make a table for the function, identify the range. Fill it out. Okay, domain, range. They gave you the domain 0, 2, 5, and 7, but those are independent. They gave us 4 random independent variables. These are dependent. It depends on what this says. This says double it. I hope you were careful when you doubled 0. I have way too many people that put 2 times 0 is 2. 2 plus 0 is 2, but not 2 times 0. 2 times 2 is 4.
Anything
2 times 5 is 10. Yeah, anything times 0 is 0. And that's all it's asking for. Please don't try to make something more complicated out of that. The range just gets repeated from the same range that it was. And I would normally have not put this in your notes, but they asked you that question in your assignment. So I thought I might as well show you that it's not really a trick question. They're just trying to try that. So this was the other rule. They gave us rules. We had to make a table. Flip-flop. Now they're giving us a table. We have to come up with the rules. X's will be the inputs and Y's will be the outputs. So we're not going to use like W and Z or A and B. We'll always use X and Y. And because we're going to always use X and Y, I want you to write up here, write a rule for the function. Our functions are always going to start with Y equals. Our functions start with Y equals. So if we take a look at the input, we stuck this into a machine, we stuck that in, that in, and that in. The machine did the exact same thing 4 times. What did it do to each one of those numbers? No.
Added 2.
It added 2. And it can't just work once or twice, it has to work every time. We added 2 every time. So from here, 1 plus 2 is 3, 4 plus 2 is 6, 6 plus 2 is 8, 10 plus 2 is 12. How do we write that as a rule? All rules start with y. We have an input. Our input is x. We're putting in an x. And we're outputting. What are we going to do to that x every time? We are going to add 2 to it. So that's what our function box is doing. So when we put in a 6, we're going to get out an 8. That's the rule that we're trying to make. Put in an x, add 2 to it while it's in the function box. It needs to be written like this, please. We're working on our translating and going verbal to mathematical. Same thing here. We didn't stick a 2 in the function box and then add an x to it. We started with an x, and once we had the x, then we just went from there. I always miss this little button and then it doesn't go. Oh, we need the next page anyway. So there's practicing doing a rule. When given a table, can you write a rule when giving all this information about a word problem? Now, be careful. This word problem isn't the 5-step solving that we just did yesterday and did in our notes. You're buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. So we're just basically writing, it says write it as a function. That basically just means that we need a rule. I'm going to have you guys cross this off. Identify the independent and dependent variables. Those are going to be x and y. Let's just use x and y all the time. Just cross it off. And here it says, then identify the domain and the range. And if you saw what we just did in the table, it is much easier, I think, to identify the domain and the range first, then make the rule. Or in this case, they call it the function. You can buy up to 6 tickets. But you know what? You don't have to buy any of those tickets. I'm not spending $15 going to a concert. I'm going to spend $15 on going to a baseball game. Probably up in the cheap seats. So 0 tickets, or you can buy 1, 2, 3, 4, 5. But the most you can buy is 6.
Dang, that's a lot of money you're buying. Or spending and buying.
Yeah. A lot of money, because if you do the range, but you're probably going to divide it between the 6 people that come with you. If you don't buy any tickets, you don't have to spend any money. If you buy 1 ticket, you'll spend $15, but you'll be there all by yourself. If you buy 2, congratulations, you're on a date. If you buy 3 can be a crowd sometimes. That'd be $45. 4, if you're taking your whole family. And 6, you found a stray guy on the way in, he's going to sit by you. So your domain is 0, 1, 2, 3, 4, 5, 6. Your range is 0, 15, 30, 45, 60, 75, and 90. That makes it easier to make your rule. We said all of our rules are going to start with y equals.
So y equals x times 15.
15 times x, yes. And we are going to write it mathematically proper. Yes, you get the same answer if you write x dot 15 or 15 parentheses x, but we've been working and working and working on writing them mathematically proper. So y equals 15x. So that's functions as rules and tables. Hang on one second. The end.